G'day, I'm Mike Rees, and I'm in front of the Seawind 1160 XL. I want to talk about performance. We've had a number of customers asking us, okay, I've sailed on 1160 Light or I've sailed on 1160, I know those boats perform, but this 1160 XL has got higher freeboards, it's got wider hulls. How can you guys make sure or guarantee that I'm going to get similar performance on the 1160 XL? Well, in this video, we're going to talk about some of the little tricks that we've got up our sleeve to make sure that the 1160 XL performs just as well, if not better, than her predecessors. First of all, let's talk about what kind of performance we're looking for. I think quite often people are looking for that top end number, what's your max speed? But really, when you're talking about sailing performance, one of the key things is, at what point can you start sailing? And that really comes down to a few different factors. The key points that we're going to look at are power to weight, which is critical for any kind of moving product, and slenderness of the hull shape. So when we did the design brief for the 1160 XL, we knew we wanted to completely re-engineer the hull and the deck. We needed to meet ISO category A, and with that, we took the opportunity to just look at everything with a clean sheet of paper. We managed to optimize the laminates, so we pulled some weight out of the boat, but even with that, we knew we had to reduce some weight dramatically because of the additional volume we put into the boat. As soon as you start putting higher freeboards on, you've got more surface area equals more weight. We've got wider hulls, more surface area, more weight. So we took what we learned on the 1190 Sport, a sport model that we've been producing for a number of years of the 1160. It's a dagger style rudder boat, nice and lightweight and performs very well. To be able to get that boat to perform well, we recognised that we needed to put carbon in place of the E-glass, and we took the same approach when we did the 1160 XL. Wherever we had high load areas using E-glass, we swapped those out to carbon unidirectional E-glass. So for example, at the base of the main bulkhead, you've got 21 layers of unidirectional E-glass, 300 gram layers of E-glass. Now, we can swap that out from 21 to 7 carbon 300 gram E-glass layers and still have the same engineering outcome. But it's not just the fiber material we're dropping down, we've also got 1/3 of the resin material that goes with it. So when you do that with those high load areas, you strip down weight very quickly. Next, let's look at sail area. The 1160 XL, we've managed to increase our sail area by pushing the forestay up higher, giving us an additional 5 square meters on the jib. Particularly useful on a catamaran with a self-tacking jib. You have these small self-tacking jibs, which typically are complemented by a screecher or a genoa, but when you're doing your upwind work, having a slightly larger self-tacking jib is definitely an advantage, and providing additional power to the boat as a whole. So with an impressive sail area to displacement ratio set for the 1160 XL, let's talk about hull shape. The slenderness of your hull shape is really important for performance in a multi-hull. If you have a wider, more full hull shape, it's going to be much harder to press through the water. That's why you've got your larger charter catamaran style boats that take a lot more to get them going, typically 10 knots of wind plus. Whereas a Seawind has always had quite a slender hull shape. We have less internal volume than the big charter guys, but that's why we can perform so much better. With the 1160 XL, we decided to go to a reverse bow shape. Now what that does is not only gives you greater waterline length, which is one of the determining factors for your overall boat speed, but also it pushes buoyancy forward. So when you've got a narrow entry and a further forward with your buoyancy, you have less hobby horsing effect when you're sailing through those choppy conditions. So essentially you've got a more stable platform, and once you get the boat stable, you're able to perform much better. There's nothing good that comes out of rocking a boat backwards and forwards in terms of driving the boat, especially when you're going upwind.